Hello everybody and welcome to this YouTube video, and today we're going to start with a new algorithm which is a supervised learning algorithm with a support vector machine. And this is one of the powerful algorithm and a more clean algorithm to work on. So in this video, what I'm going to do is that I'll make you familiar with the support vector machine, actually what a support vector machine is, and optimization objective, or we can say our cost function for a support vector machine. The support vector machine cost function is sometimes something similar to the logistic regression cost function, so this will be not that difficult to understand, but some kind of concept like a large margin intuition kernels are a little bit hard to learn, but I will make sure that I present you the simplest explanation that I could. Okay, so now in this video we'll not focus on that kind of advanced topics. We'll focus on the cost function and the introduction part of the support vector machine. So first of all, what is a support vector machine? SVM is a supervised learning machine learning algorithm that is used for regression and classification both, but you will see that support vector machine is mostly used in classification problems, as it is better than logistic regression that I found. As logistic regression has own advantages and SVM has own advantages, but I think that I would choose the SVM if I get that kind of machine learning model. It is based upon what kind your machine learning project is. Okay, so we'll talk about the difference between a logistic and a support vector machine in our later videos. But now, support vector machine is a supervised learning algorithm, and it is both. We can use this in both regression and classification problems, but mostly it is used in classification problems. Okay, now it is one of the powerful and clean algorithm that you can understand. It means it is one of the powerful is the key here. Okay, just the two things that I have to make sure about the supervised learning support vector machine. As we have talked about the logistic regression cost function, I'm saying to you just to write again that if y equals to 1, then our equation would be the log of h of xi. Okay, and here h of xi is the sigmoid. It is not it is not a linear regression, it is a logistic regression, so we use the 1 by 1 plus e to the minus z, and z here is the theta transpose x. Okay, I had just recapitulated you, but now if I talk about if y equals to 0, then we have a log of 1 minus h of xi, and here again this is our favorite 1 upon 1 plus e to the minus z, and minus z is the theta transpose x. Note here, we usually denote z, means in I denote z as a theta transpose x, or a lowercase z, theta transpose x. Okay, I will be mentioning these in my when I talk about the theta transpose x. Okay, so this was the same when we pull in together this y equals to 1 and y equals to 0, we get this kind of our cost function, which is this j of theta. And what we have to do, we have to minimize our theta. Okay, now I think that you had recapitulated our logistic regression cost function. Now we're good to go about the support vector machine cost function. So in this we have our in logistic regression we have our if y equals to 1 visualization, or a diagram, or etc., how we can represent it if y equals to 1 in logistic regression. So here we have a y, if y equals to 1, then z would be greater than 0. It means theta transpose x would be that greater than 0 if and only if y equals to 1. Yeah, no, if if it is greater than 0, then it will, or we can say greater than 0, so that it can give our value to 1. And the visualization of when y equals to 1 of our logistic, it is logistic, just now it is logistic, so it is something like that. Okay, now in case of the support vector machine, it is little bit changed. When in support vector machine, when y equals to 1, it will something like this. So let me write this here. Note that I think so this not be visual. Okay, and this is the straight line. This is the straight line. It simply means something like this. Okay, and here again I'm going to show you that here we have a same, and we draw the same thing here. We pull out here till here. Okay, and the red shown here is the SVM when y equals to 1. Okay, when y equals to 1 and it is cost of 1 of z, and z here is the theta transpose x. Again I'm recapitulating. This is for the blue line here. The blue line here is for the for logistic regression when y equals to 1. And this is simply means that 1 by 1 plus e to the minus z, and z here is the theta transpose x. Okay, and again the red one here, let me choose the red pen. Yeah, the red one here is the cost of when y equals to 1, so we denote 1 here for when y equals to 1. And when y equals to 1, we usually write cost of 1 of z, and z here is the theta transpose x, and we can write as 1 by 1 plus e to the minus z. Okay, this is for logistic, and theta transpose x is for our support vector machine. Okay, just to recapitulate again, that here we have a cost of 1z, and z here is the theta transpose x. We will see just the details of cost 1z just after this slide. And if our, also let me take eraser here, if our y equals to 0, when y equals to 0, in logistic regression we have a diagram something like that, and here the theta transpose x, the theta would be the far less than 0, or we can say minus 1. Okay, just the same. And this is the case of a logistic regression, and in case of a support vector machine, it will go down and it will go above, something like that. Okay, and here we usually denote this as a cost of 0 when y equals to 0, z, and z here is the theta transpose x. Okay, nothing to worry about it. This is pretty similar. It is for when y equals to 0, and again I'm saying here, note so that you can, the red one marked is support vector machine, and the blue one is logistic regression. Okay, so this was the cost 0, and this was the cost subscript 1 when y equals to 1 and when y equals to 0. It never goes down to that side. Okay, it's just plain here and going above. It's a diagram of when y equals to 1 and when y equals to 0. Okay, and in support vector machine we have talked about the z equals to theta transpose x, and we can show you here is that cost of 1, z is the cost when y equals to 1. So here z is the theta transpose x, again I'm repeating this times by times, is the cost when y equals to 1. Okay, and if I talk about the cost when y equals to 0, is that the again cost of 0, Z here again it is theta transpose x when y equals to 0. And you might be thinking, hey, what is the cost of theta transpose x? So wait, so if y equals to 1, the cost of 1 is equals to the max, is the max of 0, if the max of 0, k times 1 plus z, and z here is the theta transpose x. And you might be very confused after saying this statement. Just to listen me carefully, is that k here is the constant term, and it is the slope of the line. It is the slope of the line. And what is the line there? In the previous we had talked about the so here again, if y equals to 1, if y equals to 1, our SVM would be something like that. If y equals to 1, okay, and the slope of this line, the slope of this line is the k. The slope of this line is the k, slope, when y equals to 1. And when y equals to 0, then the maximum, this is max of maximum, k again is the constant term, k again is the constant term, and it will, if y equals to 0, this is something like this. And we have to take the k is the slope. Okay, and again you can find the slope, and slope equals to change in y upon change in x. Okay, that's very pretty easy to understand. Again, cost of 1 z equals to the maximum of 0 comma k times, where k is the constant term or the slope of the line when y equals to 1 plus 1 times 1 plus z, and z here is the theta transpose x. Okay, so I think that was the cost of 1 and cost of 0. So I think this would be pretty clear to you. Now let's go on to further. Now we have talked about data. Again, in the logistic regression, we have given if y equals to 1, we have this equation, and if y equals to 0, we have this equation. And in SVM, we are given, the cost of 1 of z when y equals to 1, when y equals to 1, and cost of 0 of z when y equals to 0. And here again I'm saying that max that okay, this is all. And this logistic regression cost function is pretty similar to that. So yeah, here is the logistic regression, regularized logistic regression cost function. So it is a regularized, and here we have a lambda, which is a regularization parameter. And if I talk about the support vector machine cost function, in this case, if we merged both if y equals to 1 and y equals to 0 equation and make this kind of cost function. Okay, and in case of the support vector machine, what I can do, so let me start writing that. Again, we have 1 upon m, I equals to 1 to the m, where m is the number of training examples, yi, and here instead of this is for y equals to 1, we'll write cost of 1 upon cost subscript 1 of z, and z here is the theta transpose x. And again the same thing, we only have to change the when y equals to 1 and when y equals to 0 times the cost, if this is for y equals to 0, cost of 0 of z. Okay, and at last we can add our regularization parameter, which is 2m z equals to 1 to n theta squared z. Okay, and here this is the equation for our j of theta for our support vector machine. And again I'm saying this is when y equals to 1, this is also y equals to 1, when y equals to 1, this is something like that. We simply, okay, when y equals to 0, this is something like this. Okay, just a small change in the equation, but something is left. We can optimize the support vector machine cost function by removing this. So it doesn't matter, it does not affect our cost function seriously, because it's a type of optimization of our cost function. So we have removed the 1 by m from here, and this is the optimized cost function of support vector machine. Okay, and again we have added a lambda 2, and again 2 we have eliminated here m here, okay, for optimization techniques. Now again something is left by convention of a support vector machine. I'm again recapitulating. By convention, it is by hard convention, it is told that the cost function of a SVM, so the regularization parameter of the support vector machine, should not be this lambda. Instead of lambda, we have to add c. Again, this is the same thing you can do, where c equals to the 1 by lambda. Okay, again this is the same, where c equals to the 1 by lambda. Again I'm saying, so let me write this so to be very clear to you. C equals to 1 by lambda. Okay, by convention it is given by some other who has created a support vector machine. By convention, it is given the name c as a regularization parameter, and we always put this at a first and remove this lambda. Again, you can calculate the same thing, you will get the same result. By convention, you do this. Again, 1 by 2 to the all to the and number of training examples, except 0. And what I tell, except 0, because we don't have to pin or regularize our theta 0, because we don't want to penalize our theta 0. So that's why we separate out theta 0 from that, and then we start regularizing. Or we can start with the z equals to 1, not 0. We will start with a z equals to 1, and it's just good to go. No need to separate theta 0, because it is already separated. Okay, and if you want to regularize, again I'm just recapitulating. We have talked about how increasing lambda and decreasing lambda in our previous video, what solution it can fix. If you reduce this regularization parameter, which is a c, to reduce overfitting, and which is high variance, and if you increase c, which is a regularization parameter, you will reduce underfitting. You will see your model, what is that, and you can get the results. Either you increase c or decrease c, if you have to, or if you wish to regularize your model. Okay, and I think this is the very long video. Yeah, this is the very long video but this is the very important and the powerful algorithm that will perform, that will very important for a data scientist or machine learning engineer. Okay, so I think that's it for this video, and I hope that you got better intuition about the support vector machine's cost function, and also got familiar with what is a support vector machine. Okay, and in the next video we'll go with something advanced topic, which is a large margin intuition, and also we'll see that what is a kernels. Okay, so I'll be catching up you in the next video. Till then, bye bye.